In this episode of Remote Trigonometry, we will be doing an example using a sum and difference identity to help us rewrite an equation and then solve the equation. There's really infinitely many identities. An identity is just a rule which is true for all values of x. There are some common identities that come up pretty often, and the sum and difference identities fall in that category. We can't really do every possible example of using identities to solve equations, but you should be aware that there are these identities, and often equations and other processes can be rewritten in a more convenient form by using them. So here we have the equation sine of x plus pi over 6 minus sine of x minus 7 pi over 6. And we're curious what values of x will make that equal to the square root of 3 over 2. So I'm going to rewrite both of these sine of a sum and sine of a difference using the sum rule for sine and the difference rule for sine. So sine of a sum says sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. So notice I take sine of one of the terms and multiply it by cosine of the other term, and then I swap. Now when I have a difference, I follow that same pattern, but instead of adding, I'm subtracting. So when you subtract in the sign, you're going to subtract in the difference rule. Now cosine of pi over 6 and sine of pi over 6 are among our nice angles that we should be able to get the exact value, so we don't need our calculator to do that. Cosine of pi over 6 is equal to the square root of 3 over 2. And sine of pi over 6 is 1/2. So this expression becomes the square root of 3 over 2 times sine, and this expression becomes 1/2 times cosine, and we're adding. Then we have this subtraction, so I've carried that through. Cosine of 7 pi over 6, now remember where 7 pi over 6 is. 7 pi over 6 is down in quadrant 3. And cosine is negative in quadrant 3. So cosine is negative square root of 3 over 2. Sine is also negative in quadrant 3. So sine is equal to negative 1/2. Cleaning that up, we have the two terms from the first part of the equation, and then we're subtracting, but this value is negative, so subtracting a negative changes that to addition. And careful here, I have 1, 2, 3 negative signs, so these two cancel to make an addition, but then I'm subtracting from this one. So this term will be minus 1/2 cosine. Notice the positive 1/2 cosine and the minus 1/2 cosine cancel each other out to 0. And then what I have left is the square root of 3 over 2 times sine for both of these terms. So I have 2 of them. So 2 times the square root of 3 over 2 times sine is equivalent to the square root of 3 times sine, because the 2 times cancels the 2 in the denominator. And then the whole expression was set equal to the square root of 3 over 2. So I haven't done anything with that side of the equation. To get sine by itself, I'm going to divide by the square root of 3. And whatever I do to one side, I do the same thing to the other side. So I divided by the square root of 3. I divide this side also by the square root of 3. Notice the square root of 3 in the denominator cancels the square root of 3 in the numerator. And I get sine of x equals 1/2. Well, again, 1/2 is one of our nice angles. I certainly don't need my calculator to do inverse sine on that.